Joel Rutherford. I'm the building construction and carpentry teacher here at Muscle Shoals Career Academy, and today I want to talk with you just a little bit about building materials, fasteners, and adhesives. There will be a written portion, be a written test that goes along with this. There'll be a hands-on portion, and your worksheets or Edmodo quizzes will also be counted as a grade. So here we go. All right, some of our objectives, we want to identify different types of building materials, state the uses of different types of hardwoods and softwoods, and we're going to talk a little bit more about what hardwood and softwood is in just a few minutes. We want to identify different grades and markings of building materials, talk about safety. We're going to describe the proper method of storing and handling materials, which is something that's very important for a person entering the skilled trades. We're going to talk a little bit about engineered lumber, and I want you to understand the uses of different types of that. We're going to do a little bit of estimating, just calculating quantities of lumber and wood products. And also we're going to talk a little bit about fasteners, anchors, and adhesives. Now, wood has several advantages as a building materials. It is easily worked, it has durability, and it can be made beautiful. It absorbs shock, it doesn't rust or corrode, it is light in weight, and it can be used for a variety of purposes. Now, as we know, wood comes from trees, and I want to talk just a little bit about that process. Obviously, we know that trees grow during the spring and summer, but in spring, especially early spring, tree growth is more rapid. As the summer wears on and it gets drier, the growth will slow down a little bit, and that is kind of what makes the rings in a tree. Now, these rings are made of cells, and the substance that binds these cells together is called lignin. So make sure that you are paying attention to that term there. If you look over here, you'll see the difference in these two types of wood grain. And you can also see the different cutting patterns here. Plain sawn lumber, in contrast to quarter sawn, is produced when the cuts are made at an angle less than 45 degrees with the growth rings. There's two types of wood. The first type is softwood. Softwood comes from trees that keep their leaves throughout the year. Hardwoods come from trees that shed their leaves after every growing. Now you have to be careful because sometimes hardwood is softer than some softwoods, so you want to keep that in mind. Before lumber can be used, the moisture's got to be removed. If we use lumber that has not been dried out, it will warp and twist and crack and make a huge mess. Most times lumber is dried in a kiln. They put it in an oven so that the temperature and humidity can be controlled. And if you see, and it's pretty common, a piece of lumber that's marked with a KD, that means that it was kiln dried. And these other markings also have meanings. We're going to talk about some of that in just a few. A little bit about lumber defects. A crown is a board that is crooked from one end to the other. It'll rock if it's laid on one edge. Now, almost all boards have some crown in them, and we use them, but we always use crowned boards with the hump pointing upward. This is called crowning. Now, if a board is really got a large crown in it, you don't use it. You'll put it to the side. But always make sure that you look at your lumber and see that you put the crown up. It's very important. A twist, it's just kind of like a corkscrew. Twisted lumber is difficult to use, and 99% of the time it needs to be thrown away. All right, now here's a lumber stamp here. A is the inspection trademark. B is the mill identification. C is the grade. This is standard D grade. The species identification here, you can see this is fir. Moisture content at the time of surfacing. S dry, you can look over here, S dry means 19% moisture. MC15 is 15% moisture. And SGRN, you can think of it as green, has got over 19% moisture content. Now, dimension lumber, softwood is the most common type of dimension lumber. It's divided into three categories. Number one is dimension lumber. This includes light framing lumber. This type of lumber, this is the type of lumber that's used to build houses. So you want to make sure that you pay close attention to this statement. Sheathing boards, just regular boards, are the type of boards that are included in this category is sheathing and lumber. These types are used in concrete form. And timbers, which is beams and stringers. So you can see right here, 1.5 inches by 3.5 inches. All right. Now, all framing lumber is kind of like the 2x4. The actual dimension differs from the nominal dimension. And this table will tell you here that the nominal size of a 2x4 is 1.5 inches by 3.5 inches, like we talked about. The nominal size of a 2x6 versus actual size, 1.5 inches by 5.5 inches. Now, on a 2x8, instead of it being 7.5, it's actually 7.25. A 2x10 is 9.25, and a 2x12 is 11.25. So that is something that's really important that you remember as you move forward in your career. The actual name of it is OSB. And there's the other type is called plywood. Plywood is made out of different plies. So you can see here the plies on these two boards. Plywood's made by gluing together layers of wood. The grains turned at right angles to each other in each successive layer. That's what makes it strong. The standard size for a sheet of plywood is 4 feet by 8 feet. Exterior plywood is made with a waterproof glue. I mean, it's very expensive. There's some common thicknesses here. 1/4 inch is used in cabinetry and woodworking. There's also 3/8 plywood, 1/2 inch. There's also a 5/8 and 3/4. These are used in more frame construction. Now, the grades of a plywood. The highest grade that a piece of plywood can receive is N, and then the next one is A, B, C, and D, with D being the worst. So if you had a piece of AA plywood, both sides would be really nice. If the grade was AD, then you would have one good side and the other side would have defects. Another type of plywood, which is CDX, is CD plywood, but it's also treated with an exterior type glue. It's not exterior plywood. I wouldn't use this in any kind of application that was going to be outside long term, but it is more durable with regard to being exposed to moisture than normal plywood. All right, let's talk about hardwood plywood. These are your oaks and birch plywood and things of that nature. These are used mostly in cabinetry. They'll have different type of cores. Now the core is the center layer in a piece of plywood. Some of these types of hardwood plywood can have particle board. Some have a veneer core. Some have a fiberboard core. And your highest quality plywood would have a lumber core, which would be just a full piece of lumber rather than using some sort of particle board or veneer or fiberboard. Engineered panel products. These products are made by mixing sawdust with vegetable, mineral fibers, wood chips, scrap, pretty much anything and everything. The mixture is heated and passed through a press, and it makes hardboard. It can also make particle board, oriented strand board, and fiberboard. Make sure you take note of that. Okay, temper hardboard can be used in exterior applications, so remember that. Let's talk a little bit more about OSB. It's different than wafer board, and the reason it's different is because the wood fibers are arranged in such a way that maximizes the strength of the panel. It's cheaper than plywood, although not quite as strong and not quite as high quality, but it is cheaper, and for this reason it's very commonly used. OSB will break down more quickly than plywood when it's exposed to moisture. That's the reason anytime you see a house going up and the guys put the OSB on the roof and then they let it get rained on, that's a bad thing. Really bad. We don't like to do that. If you're ever on a job site and you have any sort of say-so, you might want to keep the plywood roofing materials covered. Alright, there's another type of OSB that's called 3/4 tongue and groove. It's made with waterproof glue. It's got to be glued down, and normally it's for flooring. Now you can see here the tongue and groove. These pieces of plywood just stick together. When they're used, like these types of pieces of OSB will have little holes in the tongue, and what that does is that allows any moisture that may accumulate to pass through. So if it rains, the water will sort of just go on through those holes. This stuff, there's two different types of this. One type has been treated with an exterior glue, so it won't hurt it if it gets wet. The other type is just has a regular glue on it, and it will come apart quickly if it gets wet. So I would encourage you, if you ever are faced with this decision, to spend a little bit more money and get the flooring that is treated with the exterior glue. Alright, engineered lumber. Those are lumber products that are manufactured by binding wood particles or strands together. You can see by looking at this piece of, this is LSL, I think, laminated strand lumber. It's got just strands of lumber that have been banded together and glued to make a pretty nice looking beam, in my opinion. LSL can be used for doors, windows, and any other product that requires a higher grade of lumber. Now this at the bottom, this is an LVL, and it's a little different than this LSL up here. We're going to talk. LVLs are manufactured similarly to plywood, but the difference is the plies and all of the grain in the plies is all running the same direction, and this allows this piece of engineered lumber to be pretty strong. And you can see here normally they're used as a beam or a girder. So that one is looks like it's under the floor, but these are also used as headers in a wall. A lot of times, if you have a large room with a long span, you'll use these LVLs to carry the weight. Here's an example of a glue lam beam right here, and what it looks like to me, the way I remember this, is it's just basically 2x4s that are glued together to make a beam, and they use a high quality glue, and it makes a strong product. Here, let's see if I can get, this is a glue lam, and you can see these are arched glue lams as you go back through there. So pretty neat stuff. Here's an example of some wood I-beams. Let me see, right there. These have OSB for what's called the webbing, and the top and bottom cords are made with something akin to a 2x4. This picture is on your test, so remember that these are wood I-beams. Let's talk a little bit about concrete. Concrete is a mixture of 4 ingredients. Aggregates, there's 2 types of aggregate, fine aggregate and coarse aggregate. Basically that is sand for your fine aggregate and gravel for the coarse aggregate. You add something called Portland cement to that, and then you add water. And when you add those together, you get a chemical reaction, and the chemical reaction is called hydration. And this reaction is what causes concrete to harden. Concrete does not dry out. Like I said, it's a chemical reaction. Little crystals begin to form, and that's what binds all of the particles together. This building here, which is the Sydney Opera House, believe it or not, in Sydney, Australia, is made of concrete. So concrete's a very versatile material. There's a lot of things you can do with it. So here's the ingredients. You got, like I said before, Portland cement, coarse aggregate, fine aggregate, and water. For those 28 days, it's called green because it has not reached what's called the design strength. Okay, next we're going to talk about concrete masonry units. Now, these are sometimes called cinder blocks. Cinder block is not the proper name for these. These are called either 8-inch blocks, or sometimes they're just called blocks. The dimensions are 16 inches long, 8 inches tall, and 8 inches wide. This picture of a house that's framed up with steel studs is pretty neat, in my opinion. I've only seen one house that was framed up with steel studs. They're just not very common, especially in the southeast. Now, there's several advantages to using steel studs. Number one, although they're not combustible, if a house did burn and it was built with steel studs, the steel studs would be ruined. They're uniform, so they're all the same. There are no defects. They're lightweight. They don't rot, but they probably would rust after a period of time if they were exposed to the weather for long enough. They're easy to use, and finally, they have pre-punched holes for pipes and wires. Okay. So that would keep your mechanical contractors, plumbers, and electricians from having to drill holes in the studs to get wires and pipes through. If a stud is considered light gauge, if it's made with 25 gauge sheet metal, they're pretty flimsy. Heavy gauge studs are made with 20 gauge sheet metal, and these are pretty substantial framing members. You have to cut them with a electrically powered saw. You can't use snips, so they're pretty stout. Now we're going to talk a little bit about safety. The responsibility for a worker's safety rests with the workers. Employers do have a duty to provide a safe workplace, but at the end of the day, workers need to be taking responsibility for their own safety. So that's why we say that the ultimate responsibility for workplace safety rests with the worker. One of the ways workers can stay safe is by using PPE. Now there's a lot of different types of PPE, which, by the way, PPE stands for Personal Protective Equipment. And there's lots of different types. We're only going to talk about your four basic types of PPE right now. Number one is gloves. These should fit properly. Number 2, safety glasses. 3 is hard hat. And 4 is hearing protection. You could also categorize boots, steel-toed boots on this slide, but these 4 items make up your basic PPE system. Now, years ago, the Occupational Safety and Health Administration, which is OSHA, identified 4 categories of accidents and called them the Fatal 4. I think they've changed the name now to Focus 4 because they want us to focus on it more and focus on not getting hurt by one of these instances. And the 4 types are falls. So you could fall down, you could trip or slip, or you could fall off of a ladder or fall off of a building either. Caught in between, so you could get caught between some equipment and a stationary object. Electrocutions, you could get electrocuted, or struck by. Now, struck by, you could be struck by a moving piece of equipment. You could be struck by an errant nail that's ejected from a nail gun accidentally. So there's several ways that several subcategories under these categories. But these 4 types of injuries led to 57% of worker deaths in 2010. So that's a pretty high percentage. That's why we need to focus on these and make sure that we don't fall prey to one of these types of injuries. Lifting procedures, guys, I always lift with your legs. Most people know somebody that suffers from back pain, and it is no fun, I can tell you personally. So when you lift something, don't do like this guy. Don't bend over at the waist and pick something up. The idea is that you squat down and grab whatever you're picking up and use your legs to lift it. All right, treated lumber. Now, treated lumber is lumber that has been treated with insecticides and preservatives. And what these insecticides and preservatives do is helps the lumber to keep from rotting, decaying, or being eaten up by termites. Normally, treated lumber is green or yellow, so that's what treated lumber is. And the reason we're talking about this right now under the safety heading is because when treated lumber is burned, it releases the preservatives and insecticides into the air. So if you are around treated lumber and it's being burned, you are breathing in that smoke and you're breathing in chemicals into your body. So if you're around treated lumber, don't burn it. Just throw it away. Let them take it to the dump. It's much safer to do that than it is to burn it up. All right, now we're going to talk a little bit about calculating board footages. If you call the lumber company and you are ordering 2x4s, 2x6s, 2x8s, 10s, or 12s, you are not going to need to give them board footage. This is mostly used for when we're ordering hardwood. So if you're in a cabinet shop and you're ordering maple, oak, walnut, those types of things, then that would be a time when you might need to know the board footage. And when you call those types of places, they may even ask you how many feet. But what our little problem here is we've got 40 pieces of 2x4 lumber, and they're 12 feet long. Okay, so what we're going to do to calculate the board footage is we're going to take the number of pieces of lumber, multiply that by the thickness, which is 2. That's not the actual thickness, that's the nominal thickness. Multiply that by the nominal width, and then multiply that by the length in feet. And we're going to divide the whole thing by 12. And when we do that, this is what we end up with. We end up with 3,840 divided by 12, and there's 320 board feet in 40 pieces of 2x4s 12 feet long. Now, this next problem deals with estimating, and what we're doing is we're going to calculate the number of plywood sheets needed to cover a flat roof that is 26 feet by 48 feet. So take 26 times 48, and that's going to give us the square footage of the roof, 1,248. Now, if we divide the square footage of the roof by the square footage in one piece of plywood, that would tell us how many feet of plywood, how many pieces of plywood we need. So to calculate the square footage of a piece of plywood, you take the length, which is 8, and you multiply it times the width, which is 4, and you get 32. So we're going to take our total square footage, divide it by the square footage in one piece of plywood, and that tells us that we got 39 sheets of plywood. Alright, now this slide deals with storing plywood, but this rule goes for any type of lumber storage. If you take your lumber, if you've ordered lumber and you're going to stack it up and you throw it all down in a big jumbled mess, then what's going to happen very quickly is that lumber is going to warp and twist, and you're not going to be able to use it. So what we do in our class, and what you need to do if you are in the construction industry, is anytime you stack lumber, you need to stack it up neatly, put it on a flat surface. You can see, if you look closely right here, there are some boards here that's under this plywood that sort of let the air circulate under that bundle of plywood. So you want to do that, and really take a lot of care when you store your lumber. One piece of 3/4 inch plywood, which is the type of plywood that we use on the floor for our storage buildings, cost around $30. Sometimes you can get it a little bit more, sometimes it might be less, but $30. So if you think about it, that's 3 sheets of this plywood that we're looking at right here. Costs $100 by the time you pay tax. So we need to be careful with that, and we need to make sure that we don't throw it down and let it get warped. This is a common nail, okay? These are used when appearance is not important. It's just your regular old framing nail. They come in lots of different sizes. Now, this chart tells us the sizes of the nails. And that D does not stand for diameter. That is the abbreviation for penny. So I know it doesn't really make sense. It should be a P probably, but in the construction industry, the abbreviation for penny is D. And we can look right here at a 20 penny nail and tell that that 20 penny nail is 4 inches tall, or 4 inches long rather. A 60 penny nail is 6 inches, so pretty good sized nail there. Alright, this is a picture of a finished nail, okay? And if you look at the head of this finished nail, you can see it's pretty different from the head on a common nail. And the reason for that is these are used to install baseboard and crown molding and doors and chair rail and things of that nature. So they make the nails with a small head, that way when the trim carpenter drives the nail up, he can take what's called a nail set and actually recess the head of this nail below the surface of the trim. And when the painters come along, they put a little bit of caulk or a little bit of filler in that hole that's made when you recess the nail, and paint over it, and you can't see it. Okay? These are cut nails, and they have a rectangular cross section, and they are used to fasten boards to concrete surfaces. So you can actually take this nail and drive it into concrete. If the concrete's really old, you're going to have a pretty difficult time driving it into that. But if the concrete's just a few days old, you can drive it right in there with the regular hammer, no problem at all. All right, this is a duplex nail. And if you look at a duplex nail, it's got two heads on it. So this is the reason for this is it's used for temporary construction. Now I can drive this in until that lower nail head hits the wood, and it's going to hold it nice and firm. In a few days or weeks or whatever, when I get ready to wreck whatever I've constructed, when I get ready to tear it down, I've got a nice head sticking out here. I can just hook my hammer on and pop it right out. So these are made for temporary construction. All right. Panel nails. Now panel nails are used basically to install paneling. Now paneling, most of you probably know what paneling is, but it's sort of like pre-finished wood wall sheathing. It was really popular back in the 70s, and you nail it on the wall. You don't have to paint, and it's brown or white or just whatever color it is. So they made panel nails that match the color of the paneling. Could be white, could be brown, depends on what color the paneling has. They've got helical or plain shakes. Sometimes they may have a washer, and they are used, sometimes can be used on fiberglass roofing panels. Okay, anytime you are putting a screw into hardwood, and when I'm talking hardwood, I'm talking about your maples, walnuts, oaks, hickory, that type of thing, you're gonna have to put a pilot hole in it. If you try just driving a screw into it like we do when we're building our chairs, our Adirondack chairs that are made out of pine, or anything else that we made in pine, you can pretty much just drive a nail, just screw a nail right into those without splitting it. But if you try to do that in that more dense wood, which is hardwood, you're going to split it every time. So always use a pilot hole. This is a carriage bolt. You can see that the head on this is rounded, and that's just to make it a little bit prettier. That's meant to be exposed. So if you had to define a carriage bolt with words, we're going to say a bolt with an oval and unslotted head. This is an anchor bolt, okay, and it's sometimes called a J-bolt, but it's an anchor bolt. And what happens is, if we're going to fasten some lumber to concrete, we drop this J-bolt down into the wet concrete and leave that threaded part sticking up. And after the concrete hardens, we can drill a hole and drop our board down on top of this J-bolt and tighten it up, tighten up the nut, and it'll hold it firm. All right, here's a toggle bolt. And what I'll do, there's a couple of videos that go along with this. I'll post these videos into the Edmodo lesson so you can see how these things work. But these little wings that are on this bolt are retractable, so they fold up. They're spring loaded, and what happens is you drill a hole into a hollow wall like sheetrock, and you can push that bolt into the hole, and these wings will collapse. And when it gets inside that hollow cavity, the wings will spring back open and keep the bolt from being withdrawn. So, like I say, watch out for the video on the lesson on these, and you should give you a better idea of how these work. All right, this is a self-drilling anchor. It has a cutting sleeve. The cutting sleeve is used as a drill bit, and then it becomes part of the expandable anchor itself. Okay, construction adhesive is sometimes called liquid nails. This is some pretty strong stuff. It's used a lot of times when you're building floor systems to glue the plywood down to the floor systems. So that's some pretty stout product right there. All right, and now we're down to 2-part epoxy. This is good for bonding dissimilar materials. It sets very quickly, and you can see it's got 2 chambers here. So when you squeeze this stuff out, you got 2 different substances, and these kind of blend together, and that's what really makes that chemical reaction and causes the epoxy to get nice and hard. Okay, that's it. That is our lesson concerning building materials, adhesives, and fasteners. I hope you guys have learned something. Please do a good job filling out my quiz, my online quiz. I'm going to grade that. That's going to be a quiz grade for you. And as always, we'll be having a test that goes along with this. So just be on the lookout for that. Thank you for your attention and have a nice day.